Hi, here we have a nice algebraic question. Root 15 plus root 21 plus root 25 plus root 35 over root 3 plus root 7 plus root 20. Let's start our solution. In the first step, I will going to split each root number. In the first, I will going to write 3 times 5 will root 15 plus 3 times 7 give us 21. Then 5 times 5 give us 25 plus 5 times 7 give us 35 over this will I will going to write same as plus this I will going to write same as plus this 20 I will going to write 4 times 5 give us 20. Now here I will going to use the radical property that is root a times b is equals to root a times root b. So I'm going to apply it here. So the equation turns to root 3 times root 5 plus root 3 times root 7 plus root 5 times root 5 plus root 5 times root 7 over root 3 plus root 7 plus root 4 times root 5. Now next I will going to take common where root 3 bracket root 5 plus root 7 is remaining. Now here I'm going to take common of root 5. Root 5 bracket root 5 is remaining here and where plus root 7 is remaining. Over root 3 plus root 7. Now here the value of root 4 we have that is 2. 2 times root 5. Next, I am going to write this root 3 and plus root 5 in the same bracket, and this one is common, so we can write root 5 plus root 7 over root 3 plus root 7. Now here we have the solution for this. 2 times root 5 is equals to, we can write in this form, root 5 plus root 5. So I can write 2 times root 5 in this form. So I will going to write this in replacement of this plus root 5 plus root 5. In the next step, I will going to rearrange this denominator terms, and the numerator I will going to write same as root 3 plus root 5 bracket root 5 plus root 7 over this. I am going to write root 3 with root 5. If you can notice, numerator are the same sequence. So root 3 plus root 5 bracket plus we have here, and here I will going to write root 5 plus root 7. Now here I will going to suppose a is equals to this root 3 plus root 5, root 3 plus root 5, and b is equals to root 5 plus root 7. This equation turns to that is a times b over a plus b is equals to, here I'm going to suppose this will equal to x. So this is, I suppose, this whole expression equals to x. Now here I will going to simplify this expression. I will going to cross multiply. So this will turn to 1 over x, and this will go to the numerator side. So a plus b over ab. Now this AB is dividing in both the numerator values, so I will going to write in this form 1 over x is equals to A over AB plus B over AB. So now this A and this A get cancelled, and here this B and this B get cancelled. So the remaining expression we will get 1 over x is equals to 1 over B plus 1 over A. Now here I will going to recall that is A is equals to root 3 plus root 5 and B is equals to root 5 plus root 7. So now we're going to plug in these values in replacement of B and A. So the expression we will get that is 1 over x is equals to 1 over root 5 plus root 7 plus 1 over root 3 plus root 5. Now here I will going to rationalize both the denominator. So it will turn to 1 over x is equals to, what I will going to do, I will going to multiply and divide the denominator by changing the sign. So here I will going to write this in this form root 7 plus root 5. I'm going to rearrange it because here I will going to change the sign, so the negative sign will appear in the greater one. So that I don't want, so I'll rearrange it right here. So it will turn to root 7 minus root 5 over root 7 minus root 5. Plus, same here, I will going to rearrange this also. Root 5 plus root 3 because I will going to rationalize it. So the negative sign will appear with the larger number. So I will going to write this in this arrangement. Root 5 negative root 3, root 5 negative root 3. If you can see carefully, I can write this expression and hold this expression in perfect square form. That is A square minus B square is equals to A plus B, A minus B. So this will turn to 1 over x is equals to root 7 over this algebra root 7 raised power 2 minus root 5 raised power 2. One is going to be multiplied with this numerator, so it will turn to root 5 minus root 3 over root 5 raised to power 2 negative root 3 raised to power 2. Now here this and this will get cancelled. So I will get 7 here, this square and this will get cancelled. So here 7 minus 5. Plus this square and this will get cancelled, this square and this will get cancelled. So I will get root 5 minus root 3 over 5 minus 3. Now we're going to simplify it further, so it will turn to 1 over x is equals to root 7 minus root 5 plus root 5 minus root 3. Here over 2 is remaining. Here over 2 is remaining. Now here I'm going to take the LCM. 1 over x is equals to 2 is the LCM, and here 1 time root 7 root 5 plus root 5 minus root 3. This and this get cancelled, so the remaining expression we will get 1 over x is equals to root 7 minus root 3 over 2. Now here I will going to do the cross multiplication. So this expression turns to x is equals to 2 over root 7 minus root 3. Now again I will going to rationalize the denominator, so it will turn to x is equals to 2 over root 7 minus root 3 times. Now I will going to change the sign, root 7 plus root 3 over root 7 plus root 3. Now I'm going to simplify it. X is equals to 2 times this whole expression I will write down in the bracket over this. I'm going to write root 7 raised to power 2 minus root 3 raised to power 2 by using the algebraic identity. As I am going to simplify it further, it will turn to 2 bracket root 7 plus root 3 over this will going to be cancelled out. So here 7 is remaining and this will going to be cancelled out. So here 3 is remaining. Now this will turn to x is equals to 2 bracket root 7 plus root 3 over 4. This get cancelled by 2 and the expression will get x is equals to root 7 plus root 3 over 2. This is our final answer. Thanks for watching our video. Please don't forget to subscribe to my channel.